Matter is anything that has mass and occupies space, or it has volume. And these three are the general examples of matter: the elements, compounds, and mixture. Those that do not fall under these categories are called non-matter. Again, those that are not included or does not describe in any of these categories are called non-matter. And these non-matter are energy, okay, because they do not have mass, they don't occupy space. Force, okay, time, memories, right? So these are examples of non-matter. So let's have the first one, which is elements. Elements or element are made up of a single type of atom. Okay, they are also considered as pure substance, meaning they cannot be broken down to any other substance. Elements can be classified as metals, non-metals, and the other one is the metalloids. Metals are good conductors of heat and electricity, while non-metals are poor conductors of heat and electricity. Metalloids, on the other hand, has a property that falls intermediate between metals and non-metals. We will have a separate video for the properties of metals and non-metals and even metalloids. Okay, but for now, let's take a look at the periodic table. So as you can see here, the blue colored boxes represents the metal elements, while the purple, the violet colored boxes represents the metalloids. The yellow boxes represents the non-metal. Okay, by looking at this, you can easily say that there are more metals compared to non-metals and metalloids. What are the examples? Okay, how do they look like? So I have prepared here some of the images or pictures of the elements given here. So the first one, let me change my pen first. The first one is the lithium, which is covered with a dark layer of oxide. This is crystalline boron, and this is a high purity silicon that's going to be made into silicon chips that is used in computers, cell phones, and this is a crystalline sulfur. Next is a lump of calcium, and of course many of you are familiar with this kind of metal. They are used in electrical wirings, which is called copper wire. Okay, so this is an element copper, and we have here a gold sheet at the bottom, and then a small amount of toxic mercury. Okay, so these are just a few examples of the elements listed here in the periodic table. Right? So now let's go to the second example of matter, the compounds. So compounds are made up of two or more elements. Elements that are chemically bonded together. Let me write it down. Chemically bonded. Okay, when we say chemical bond, that means there is an electrostatic force that keeps the two atoms together, or a group of molecules together. Okay, so it's an electrostatic force, the chemical bond. Now, chemical bonds can be classified into three. The first one is ionic bonding. Okay? Ionic bonding occurs between a metal element plus a non-metal element. Okay? An example for a metal non-metal bonding or ionic bond is this is the most common, sodium chloride. Sodium is a metal element and chlorine is a non-metal element. Okay? The other example is, let's say, sulfur dioxide. So we have SO2. Sulfur is a metal element, okay, while oxygen is a non-metal element. The second one, let me write it here. The second one is called covalent. Okay, the covalent bond. Covalent bond occurs between a non-metal element and another non-metal element. So non-metal plus non-metal forms covalent bond. Okay. The example for this is an oxygen molecule. So meaning there are two oxygen atoms. Say let us say that this is our oxygen atom. So this is oxygen atom 1 and this is our oxygen atom 2. Now the electrostatic force that binds them together, okay, it's called covalent bonding. Okay, yung nangyayari sa kanilang dalawa. Okay, another example is H2O, right? This is a non-metal element and another non-metal element. So going back to the previous example, oxygen, again, these two are considered as non-metal elements. So second example, hydrogen gas is a non-metal element, oxygen is a non-metal element. Okay, let's have another example. Let's say nitrogen monoxide, okay, or nitrogen dioxide. So nitrogen is a non-metal, oxygen is also a non-metal. So that makes up a covalent bonding. The third one, okay, and then the last is called metallic bond. Okay, metallic bond occurs in metals. So this is a metal plus another metal bonding. Okay, like those of silver. Okay, yung example natin ay silver. Okay, iron, nickel. Okay, this three elements shows metallic bonding. Okay, and it exists between metal and another metal element. This one is a sugar. So sabi natin kanina, compound is a chemically bonded materials or elements. Okay, what are the elements involved in making sugar? So these are carbon, okay, hydrogen, and that's 22, and 11 oxygen. Okay, so this is 22, 11, and 12. So the elements involved, carbon, hydrogen, and oxygen. For baking soda, or otherwise known as sodium bicarbonate, the elements involved are sodium, hydrogen, carbon, and oxygen. Right? And then for sulfuric acid, this is the sulfuric acid. Let me write it down first. Okay, so it is a bonding, okay, of three elements: hydrogen, sulfur, and oxygen. Salt, this is the most common, a bonding between sodium and chlorine. I have here water, H2O. This one is hydrogen peroxide, and this one is muriatic acid. Muriatic acid is hydrogen and chlorine. Right? So now, let's go to the last one, which is mixtures can be categorized into two based on their components. The first one being homogeneous. Okay, homogeneous mixture. Then the other one is heterogeneous mixture. So we will go to that later. First, let's define mixture. So mixture is a physical combination of two or more different materials. So physical combination. Meaning, you combine the materials together and there is no chemical reaction. Okay? Chemical reaction is absent. Homogeneous mixture, technically, if you are going to take a look at it, you will see a uniform appearance. Okay? Uniform appearance. Okay? Meaning, you cannot identify the other components anymore. If the two or more materials are mixed, then you cannot identify which are the components. So that is a homogeneous mixture. In fact, there is a test that can be performed to determine whether a material can be considered as a homogeneous or heterogeneous. Okay, you can do the scattering of light, or the Tyndall effect. So Tyndall effect is like this. So all you have to do is prepare 2 glasses of water. Okay, fill it with water. Again, yan. Right? Then lagay ka ng cardboard dito. Tapos flashlight, or mas maganda kung laser pointer. Okay, and then beam the laser pointer. Okay, the tendency is you will see, let me change the color of my ink to red. So the tendency is, if this is your laser pointer, okay, you will see the reflection here. Okay, the ray of the light. Okay, nandito na siya sa board. Okay, now you cannot see any light that passes through the glass of water. Maybe the light that you can see are just reflection that comes from the glass, okay, or from the air to the glass. Okay, kaya siya nagre-reflect ng pag ganon. Okay, or dito, pag ganon. But you will not see the path of light through the glasses of water. Now, add, let's say 1/4 tablespoon of salt in glass A. Let's call this as our glass A, and this is our glass B. So in glass A, gawin mo, ulitin mo lang, ano ka ng laser pointer, hindi mo pa rin makikita yung path of light because the appearance is uniform, homogeneous. The salt particle are too small, that is less than 1 nanometer. Okay, less than 1 nanometer. Okay, the particle is too small that it cannot reflect or cannot bounce back the light that comes from the laser pointer. Now, leave glass A as is. Now, for glass B, I would like you to put a 1/4 teaspoon. Okay, 1/4 teaspoon of powdered milk. Okay, powdered milk, and then stir it thoroughly. Once you turn on your laser pointer, you will see a beam of light passing through the glass B. That is because the particles of powdered milk are big enough. They are big enough to reflect light in different direction, right? In different direction, like that. So all of the particles reflect. That's why you are able to see this. So if you can see this, that means the mixture can be considered as a heterogeneous. Okay, maybe because the particles are more than 1,000 nanometers. Alright, so this is one of the good way to test whether a material is really a homogeneous or not. Okay, so that is just an example. Now, what about the examples of the homogeneous mixtures? So the first one can have a salt solution. Okay, that is salt plus water, right? You can have sugar solution also. That is sugar and water. And the third one is instant coffee plus water again. And then the fourth one is alloys. These are solid homogeneous mixtures. It can be steel, which is made up of iron and a few amount of carbon. When carbon and iron mix together, you cannot identify which is the carbon, which is the other materials in the whole. Or brass. brass is a mixture of alloy and mixture of copper and zinc. You mix the two together, you can identify which is the copper, which is the zinc. They become an alloy. They become a homogeneous mixture. Unlike in homogeneous mixture has a uniform phase or uniform appearance. Heterogeneous mixtures, okay, they do not have a uniform appearance. Write it down. Composition is not uniform, meaning you can see the different components of the materials, or there can be layer of materials. Example of heterogeneous mixture, pizza, right? So you can see the pepperoni or you can distinguish pepperoni from the bell pepper, okay, or from the other meat ingredients of the pizza. The second one, vegetable soup, right? You can see the different vegetable placed in the soup.